Now remember, if you are watching this video at home, feel free to pause so that you can write down the information that's projected on the board. In this problem, we're going to be factoring a trinomial, and we did simpler versions of this in the previous day's lesson. So what we're going to do is we're going to draw the box. That's going to help us organize our work. And then we take the first term, which is 6x squared, and we put it in the first box. We take the last term, which is 10, and we put that in the last box. And then we say that, remember, the product of the diagonals, meaning when I multiply the diagonals, 6 times 10, that gives me 60x squared, is also the same answer as if I were to multiply diagonally between these two boxes. And ultimately we need to fill in these two boxes with numbers. But we can't do that unless we have some limitations. So these two, whatever they are also going to multiply to be 60x squared. So I just like to write that down. Blank times blank equals 60x squared. Furthermore, we know that the two blank boxes are also going to add, when I add them together, to get 19x, because that's my middle term. So the two blank boxes will multiply to give me 19x, but they add to give me 60x squared. Now, our ultimate goal is to figure out what two numbers satisfy both of these conditions, and if we don't know, then we need to start dividing. And I take the 60 because that's being multiplied, and I divide. Well, I know if I were to go 60 divided by 2, that gives me 30, so I know that 2 times 30 equals 60. The trouble is, 2 plus 30 is not 19, it's 32, so that's not going to work. So we need to start dividing by other numbers. And you can divide as many times as you want until you find the right answer. I tried 60 divided by 15, and that gave me 4. So that means that 15 times 4 is 60. And let's try, does 15 plus 4 equal 19? I think it does. So we know that our two numbers that we're looking for are 15 and 4. But also, what do the 15 and 4 have to have? That's right, an x. So 15x plus 4x gives me 19, and 15x multiplied by 4x gives me 60x squared. So I plug these numbers into the missing boxes right here. Now, in order to figure out what my two factors are, I look at my box and I go across and up, finding the greatest common factor in these pairs of boxes. So what is the greatest common factor, meaning the largest number that goes into both 10 and 4x? I would say it's 2. Going across this way. If I'm looking for the greatest common factor between 6x squared and 15x, well, the greatest common factor between 6 and 15 is 3. And then because they both have an x, we can factor out an x as well. Then we go up. Going up in this direction, what's the greatest common factor between 6x squared and 4x? I think it's 2x. And then going up this direction, what's the greatest common factor between 10 and 15x? It's 5. Now when I look at this problem, I double check before I write down my answer. Does 3x times 2x give you 6x squared? Yes. Does 5 times 3x give you 15x? Yes. 2 times 2x, is that 4x? Yes. And does 5 times 2 equal 10? Yes. So my final answer is 2x and plus 5 and 3x plus 2. And those are my factors. let's try one more example. Let's try 4x squared minus 5x minus 6. Again, in this problem, we draw the box and make our box have 4 squares. The first term goes in the first box. The last term goes in the last box. 4x squared goes here. And this minus 6, I'm going to make it be negative 6 there. Again, our diagonal products are the same. So 4 times negative 6 is negative 24 and x squared. So my 2 blank boxes are also going to multiply to give me negative 24x squared. Blank times blank gives me negative 24x squared. But these 2 blanks are going to add to give me negative 5x. And when I look at these problems, when I know that something has to multiply to give me a negative number, I know one of the numbers has to be negative and the other has to be positive. Furthermore, since these 2 numbers are adding to give me a negative, the bigger of the 2 numbers is going to be negative. So, if I'm dividing, I can try numbers. What is negative 24 divided by? Well, let's try 3. Negative 24 divided by 3 is negative 8. And does negative 8 plus 3 give me negative 5? Well, it does. So I've got negative 8x and 3x. So I know that these are the 2 terms that I'm going to put in the blank boxes right here. And it doesn't matter where you put them, as long as you put one in one and the other in the other. Okay? Then we find our greatest common factors going across and up. So going across this direction, what's the greatest common factor between 3x and negative 6? 3. What's the greatest common factor between 4x squared and 8x, negative 8x? 4 and x. Going up, what's the greatest common factor between 4x squared and 3x? 1x. Going up this way, what's the greatest common factor between negative 8x and negative 6? 2. Now, I worry about the negatives at the very end. So, I check and make sure. Does 1x times 4x give me 4x squared? Yes. Does 2 times 4x give me negative 8x? No, but we know we could make it negative. Does negative 2 times 4x give me negative 8x? It does. Does 1x times 3 give me 3x? Yep. Does negative 2 times 3 give me negative 6? Yes. So I know my box works. I double check it. And my answer is 1x minus 2 and 4x minus 3. One more example and we'll be all done. And this one's a little bit more challenging. 6x squared minus 16x plus 8. So when I look at this problem, these look like big numbers, 16 and 8 and 6. So I look to see, is there a number that goes into all 3 of these, 6, 16, and 8? And there is. It's 2. They're all even. So I'm going to start by factoring out a 2. We've done this before. So when I factor out a 2, I divide. 6 divided by 2 is 3x squared. 16 divided by 2 is 8x. And 8 divided by 2 is 4. The reason why we do this is so that we work with smaller numbers, and also we will get the right answer as long as we factor out a number if we needed to. The other 2 examples, we didn't need to. So again, I put my first term in my first box. I put my last term in my last box. And then I multiply diagonally. 3 times 4 is 12x squared. So I know that my two missing boxes have to multiply to give me 12x squared. And they have to add to give me what? The negative 8x. These two numbers have to add to give me the middle term, which is negative 8x. Now, when I see that I have two numbers that multiply to give me a positive, but add to give me a negative, that to me means that they both have to be negative. Because a negative times a negative is a positive, but a negative plus a negative is still negative. So at this point, we are going to divide 12 divided by, and let's try 2. 12 divided by 2 is 6. 6 plus 2 is positive 8. But if we made them both negative, it would still satisfy all of our conditions. So negative 6x, negative 2x. So I put these numbers in my boxes, and I find my greatest common factors, going across and up. If I'm going across, what's the greatest common factor that goes into 2x, negative 2x and 4? Well, that's 2. The greatest common factor that goes into both 3x squared and negative 6x, well, that's 3x. Going up, the greatest common factor that goes into both 3x squared and negative 2x, that's 1x. And the greatest common factor that goes into both negative 6x and 4, to me that's 2. Again, I double check so that I can deal with the negatives. 1 times 3 is 3, good. 3 times 2 is 6, but not negative 6. But if I made the 2 negative, then negative 2 times 3 is negative 6, that works. 1 times 2, that's not negative 2, but if I made the 2 negative, then it's still going to work. And then negative 2 times negative 2 is a positive 4, so that works. So I write my answers, 1x minus 2, and 3x minus 2, or we could put plus negative 2. And then the other thing is, we factored out this 2 at the very beginning, we need to write it down in our answer. So this is my final answer. Feel free to replay any or all of this video so that you can review.